Good morning, myself Altaf Sheikh. I have been teaching chemistry since 5 years. So today we will be studying a solid state lesson which is important for our Maharashtra State Board syllabus, MHT-CET syllabus, JEE as well as for NEET. Okay, so in solid state we are going to discuss some important concepts like how to identify a solid, how we are going to differentiate solid states with other states like liquid and gas. Then we are going to classify the solids depending upon their arrangement of constituent particles like haphazard arrangement or regular arrangement. Based on that, we are going to classify the solids into two main categories. First one is crystalline, another one is amorphous. First topic, we will discuss the solid state and we compare the solid state with the other general states of matter like liquid and gas. So whenever we see any objects around us, we encounter many types of matter. Like some matter is rigid, some matter we observe that it can flow easily like water, oil. Like in gaseous state we see around like our cooking gas, LPG or oxygen gas. So if we study this different states of matter, we come to the conclusion that we can identify the three states of matter, namely liquid state, gaseous state and important one is solid state. Because the mobile you are holding in your hand is also a solid state. So after observing my mobile or your mobile, we can observe many things like the shape of mobile is remains same. It does not change easily with the increase in temperature or pressure. But in case of liquid, suppose you have a glass of water with you. If you pour that liquid on the floor, it will easily spread. That means liquid state does not remain in a shape which we occupied initially. But in case of gases, we can easily say that when we observe a leakage in our LPG gas, we observe a smell. Like the cylinder is placed at one corner of the room, the smell of the gas easily spreads to other parts. That means the gas is occupying the space of the room. That means the gas is initially has a shape of cylinder, but right now it has a shape of room. So based on that point, we can easily say that solid state has definite shape. But liquid, no definition. Same with the gas. Okay. But we also observe that the liquid changes its volume when we increase a temperature, exception of water. So when we increase a temperature, the volume of liquid also changes. But at the same temperature, when we measure a volume of three states of matter, we observe that the volume of solid also remains same. In case of liquid, also the volume of liquid also remains same. Then how we can visualize that liquid has a definite volume? Simply, you just have to do one activity. Take 1 liter of water, pour or divide into number of glasses. Then again the water which is present in the glass, pour it back into the bottle of 1 liter. You will see that there is no change of volume. Depending on that or based on that activity, we can conclusively say that liquid has definite volume. But in case of gas, like I also just now I mentioned one occurrence, that is a leakage of LPG gas. The cylinder has definite volume. In that volume, gas is present. But when it gets leaked, it occupies a volume of Then what are the other criteria to define a solid state? Then we also see that in a microscopically the constituent particles of solid states are really closely packed. That means intermolecular distances in solid state is very short. That means the distance present between the two molecules or two particles of solid state is very short. But in case of liquid, we also observe that in liquid state molecules are continuously in motion. That means the intermolecular distance in a liquid state is high. Also, in a gas state, the same point. Intermolecular distance in gas state is very high. Because in a gaseous state, the particles having more kinetic energy than that of solid and liquid state. That means the molecules are moving with a very high velocity. So the gap between or intermolecular distance between the two particles is very high. But in case of liquid, the intermolecular distance is higher than that of solid, but less than that of gas. This is the third point. Based on the third point, we can also put forward a fourth point. That is, whenever this intermolecular distance is short, then we can say that the attraction between the two particles are strong. Intermolecular or interparticle attraction is strong. That means two molecules are holding each other very strongly. Due to that, we get a definite shape. And due to definite shape, we can say that there is a definite volume in case of solid state. But in case of liquid, there is a random motion present among the molecules. Due to that random motion, we cannot say that there is a strong intermolecular forces of attraction. But intermolecular forces of attraction are present, cohesive forces of attraction, but not strong as solid state. That means intermolecular attraction is strong than that of gas state, but less than that of solid state. In case of gases, intermolecular distances are high. That means the attraction between the molecules is very less. That's why they are apart from each other. So intermolecular attraction is very less. Okay. These are some important points to differentiate solid, liquid, and gas. If we consider another criteria to differentiate among the solid, liquid, and gas state, we can compare the boiling point and melting point of the substances with the room temperature, and then we get an idea to differentiate a solid state. Okay. We can also compare the solid, liquid, and gaseous state of matter with another criteria. That means, suppose there is a substance A, we have an idea about the boiling point and melting point of that substance. Suppose we know the room temperature, and when we compare the room temperature with the melting point of A, then if we come to the conclusion that room temperature is less than melting point of the substance, then we can say that the matter is present in solid state. Then, if the room temperature is more than the melting point of the substance A, then we can say that the matter is present in liquid state. Then, how we can compare the gaseous state? Just compare the room temperature with the boiling point of substance. If the room temperature is more than boiling point of substance, then the matter is present in gaseous state. In this way, we can compare the different states of matter in different conditions, like in polar regions of Earth, where we observe minus 20 to 10 degrees Celsius temperature. That is, water is present mainly in ice form, that is in solid state. In polar region, water is present in a solid state in the form of ice. When we compare boiling or melting point of ice, that is 0 degrees Celsius, and the room temperature is minus 20 degrees Celsius. Which temperature is more or higher? That is your melting point. So melting point is 0 degrees Celsius, room temperature in the polar region is minus 20 degrees Celsius. Then we can say that water is present in the polar region is in the solids. Okay, so in this way we can easily remember the solid, liquid and gaseous state, comparing it with the melting and boiling point. So next topic we will be covering is the classification of solid state. There is a simple classification of solid state, crystalline, and another one is amorphous. So how we can come to the conclusion that solids are of two types, crystalline and amorphous? We observe its structure, and after observing its structure, whenever there is a regular arrangement of its constituent particles, like that. So arrangement of particle in crystalline solid is regular. Then we classify that solid as a crystalline solid. In amorphous word is a Greek word. Amorphous means shapeless. That means whenever we observe the structure of a solid, we observe that the arrangement of constituent particle is haphazard. That means not regular, like that. We cannot observe any irregular pattern present in the amorphous solid. That is the main differentiating point between crystalline and amorphous solid. Crystalline solid has a regular arrangement of constituent particles, but amorphous solid does not have a regular arrangement of particles, that is haphazard arrangement of particles. So this is the main important point. Then what are the other points to differentiate the crystalline and amorphous solid? You can do in your home, take a knife, cut any substances. After cutting that substances, if you get a normal surface, a regular surface, then it is a crystalline solid. After cutting with a knife, we get regular surface, then it is crystalline solid. But in case of amorphous, total opposite. You take the example of like wood. If you break a wood or cut a wood, you won't get a proper regular surfaces in amorphous solid. But in crystalline solid, you will get a proper regular surface. Take an example of sodium. If you cut a sodium with a knife, you get a very regular and smooth surfaces. But this does not happen in case of amorphous solid. Another next point is, whenever you try to melt a crystalline solid, you will observe that crystalline solid has sharp melting point. That means at a particular temperature, the solids starts to melt. But in case of amorphous solid, this does not happen. Amorphous solid does not have a sharp melting point. Take an example of glass or a plastic. Whenever you heat a glass or plastic, it first starts to smoothen, then it flows. That means we cannot identify a sharp melting point. At that point, the amorphous solids starts suddenly to melt. But in crystalline solid, we observe sharp melting point. Another important point is crystalline solids are anisotropic. But amorphous solids are isotropic. What does that mean? Isotropic means the word itself says iso means same or similar. That means whenever we observe a certain properties through amorphous solid, we get the similar property in any direction, just because of irregular arrangement of particles. Just take example of refractive index. Whenever we calculate refractive index of amorphous solids in different directions, we get the same value. But in case of crystalline solid, we do not get in all directions the same value of properties. Example, sodium iodide. Suppose a solid made up of two types of particles, A and B. Whenever we observe any property in that direction, that means in that direction, all the atoms are of same type. But in this direction, we see that there is alternate atom of A, atom of B. That's why the crystalline solids are anisotropic. Okay. Another important point is crystalline solids are hard. That means it cannot give scratches easily. But in case of amorphous solid, they are usually soft. Okay. The examples of crystalline solids are NaCl, ice, then metals, are all crystalline solid. Amorphous solid like glass, plastic, metallic glass. So the first classification of solid is crystalline solid and amorphous solid. So till now we have covered the comparison of solid, liquid and gaseous state of matter. Then we also saw the classification of solid, that is amorphous and crystalline. So amorphous solid, how we are going to classify any solid as amorphous? By looking at the arrangement of constituent particles. If the arrangement is haphazard, then we classify that solid as amorphous solid. But in case of crystalline, if there is a regular arrangement of constituent particles, then we classify that solid as crystalline solid. So crystalline solid, we again classify crystalline solids into four categories. First one is ionic solid, second one is covalent crystal, third one is molecular solid, and fourth one is metallic solid. So what is the differentiating points among these four types of crystalline solid? The first point is constituent particle. The constituent particle in ionic solid is charged ions. We know that ions are two types. One is anion, that is negatively charged, and cation, which is positively charged. So first important point in case of ionic solids are the ionic solids have a charged ion In case of covalent neutral crystal, there are non-metal atoms. Because we in the 11th standard we studied the chapter regarding chemical bonding. We know that whenever there is a bonding or attraction between the electronegative atoms, the bond is a covalent bond. So non-metals are electronegative. The electronegative atom are bonded with another electronegative atom with a covalent bond. But in case of ionic solid, cation and anion both are linked by ionic bond. These concepts we have already covered in our 11th question in chemical bonding. That means the bond present between the two electronegative atoms is of covalent bond, and the bond present between electropositive atom and electronegative atom is of covalent bond. Then we come to the molecular solid. In molecular solid, as name suggests, the constituent particles are molecules. So molecules are of two types generally. That is polar molecule, and another one is non-polar. And fourth one is metallic solid. As the name suggests, metallic solid has a constituent particle as a metal atoms. So this is the most important point to differentiate among the different types of crystalline solids. In ionic solid, the constituent particle is charged ion, that is anion and cation. In covalent neutral crystal, the constituent particle is non-metal atoms. In molecular solid, the constituent particles are molecules. And fourth one is metallic solid, the constituent particle is metal atoms. So depending upon the constituent particles, there exists certain type of intermolecular attraction. In ionic solid, anion attracts cation. That means there is some kind of attraction or attractive forces. That attractive force we call as ionic bond. That means in ionic solid, the intermolecular attraction is ionic bond. Which is present between the oppositely charged ions. That means cation and anion. Also, we'll take example of NaCl. In NaCl, sodium ion is surrounded by 6 chlorine ions. That means coordination number of cation is 6. Same with anion. Chlorine ion is surrounded by 6 sodium ions. That means coordination number is 6. In case of covalent neutral crystal, the constituent particles are non-metal atoms. Non-metal means they are electronegative. Between two electronegative atoms, there is a covalent bond. That means the attractive forces or intermolecular attraction in covalent neutral crystal is covalent bond. In case of molecular solid, because molecules are of two types, polar, non-polar. In polar, we observe oppositely charged on the two ends of molecule. But in case of non-polar, we do not observe such kind of thing. That means whenever there is a polar molecule is present as a constituent particles, we observe the intermolecular attractions are dipole-dipole interaction. But in case of non-polar, we observe Lendl forces or van der Waals forces, the force which is very weak in intermolecular forces. Another one type of attraction is present in molecular solid, that is hydrogen bonding. So what is meant by hydrogen bonding? Suppose if any molecule contains hydrogen, I will take example of HCl. And if that hydrogen is making a bond with the other molecule, and in that molecule and making a bond with an atom which is more electronegative than hydrogen, we call it as hydrogen In case of metallic solid, the constituent particles are metal atoms. Metal atom means they are electropositive atoms. Whenever there is an attraction or attractive forces present between the electropositive elements, the bond is called metallic bond. So first differentiating point among these four types of crystalline solids is constituent particle. Ionic solid, charged ions having a intermolecular attractions of ionic bond. In covalent metal crystal, constituent particles are non-metal atoms which are bonded to each other by covalent bond. In case of molecular solid, we observe three types of intermolecular attraction: being dipole-dipole interaction, tandem forces, and hydrogen bonding. In metallic solid, there is a metallic bond. And the third important point is regarding its physical properties. We observe that in ionic solid, ionic bond is strong. That means ionic solids are strong, hard, and brittle. Ionic solids are hard and brittle because of strong ionic bond. In case of covalent metal crystal, these are the strongest solid present in our nature. Best example is diamond. That means covalent metal crystals are very hard and tough. But molecular solids, because intermolecular attractions are not strong as like of ionic and covalent bond, that means molecular solids are soft and having low melting point and boiling point because of weak intermolecular attraction, low melting point and boiling point. But in case of ionic solid, there is a strong ionic bond. To overcome that bond, we need to heat it more. That means the melting point of ionic solid is high. Same with the covalent metal crystal. Due to strong covalent bond, it needs more energy to melt. It also has high melting point. In metallic solid, same high melting and boiling point. When we look at its electrical properties and thermal properties, we observe that ionic solid, in solid state, their constituent particles show only one type of motion, that is vibrating motion. That means the constituent particles cannot leave its original position in solid state. That means in solid states, ionic solids are insulated. But when it melts, then ions are free to move about. In that case, ionic solids shows electrical conductivities. Also, we should recall a scene from 3 days. That when American get lost in a room, it just moves a little bit spoon from below the door and it gets shocked. Same case with the ionic solid because urine is a salt water. Then covalent metal crystal, they are not, the constituent particles are non-metal atoms. That means they cannot conduct electricity. So they are electrically insulated. Molecular solid also insulated, but metallic solids, due to the free electrons present in their crystal, they show good electrical as well as thermal properties. Okay. Then our next topic is unit cell and types of unit cell. When we observe the crystal structure of any solid, we observe that there is some kind of pattern is continuously goes on repeating in the structure. That smallest repeating unit or structure, we call it as unit cell. So there are 4 types of unit cell. Basically, first one is simple cubic or primitive. Second one is body centered. Third one is face centered, and fourth one is end center. The first type is simple or primitive. So first type of unit cell is simple or primitive. In case of living unit cell, the constituent particles occupies the 8 corners of unit cell, and the particle present at the corner is divided or shared among 8 unit cells. That means one unit cell from this side, then from this side, like that. So the particle present at the corner is get divided amongst 8 units. So one particle is divided among 8 unit cells, and total number of particles present at the corners are 8. 1, 2, 3, 4, 5, 6, 7, 8. So effectively, in simple unit cell, there is only one particle is present. But and another second type is body cell. In body centered unit cell, 8 particles are present at the 8 corners, and one extra particle is present at the center of the unit cell. Same, one particle at the corner is get divided into 8 unit cells, and total 8 particles are present at the corner, plus one particle is present at the center. That means effectively there are two particles present in the body centered unit cell. And the next type is face centered. In face centered unit cell, the 8 particles are present at the 8 corners of unit cell, and 6 particles are present at the center of 6 faces. 1, 2, 3, 4, 5, 6. And the one particle at the face is shared between the 2 unit cells at this unit cell. That means the particle present at the corner is divided amongst 8 unit cells. Total 8 particles are present, plus the particle present at the center of the face is divided into 2 unit cells, and total 6 particles are present at the faces. So effectively there are 4 particles